In Fourier analysis, we are going to discuss four main topics. First topic is based on the Fourier series, like how do we find the Fourier series expansion of a function. Then the second topic will be based on the Fourier cosine series, like it is expressing a function in the terms of cosine terms. Next is Fourier sine series, expressing the function in the terms of Fourier sine terms, and Fourier transform. So these are the four main topics that we are going to discuss. So let's begin with the first one, Fourier series. Now what is Fourier series? Fourier series for any function f of x is given by this expression. It means we are expressing the function f of x in terms of sine and cosine terms, so that it is easy to depict their behavior. Now, this function f of x is defined over the interval of the c to c plus 2l. So, we can write the interval like this, or we can write it as c to c plus 2l. This is another way of writing the interval. So, remember that this is the Fourier series expansion of the function defined over this interval c to c plus 2l. Okay. Now, in this Fourier series, the quantities which are written by red color, we need to find those things. So, we need to find a0, an, bn, and as well as l. For finding a0, we have this formula 1 over l c to c plus 2l. It means over the interval for which the function is defined, fx dx. For finding an, we have this formula, and for finding bn, we have this formula. Now, there is no formula for L, for finding L. So, how do we find L? So, to find L, we compare the given function with the interval of the given function with this one. Like, okay, I want the length of the interval c to c plus 2l. So, what it will be? For example, like if we say that this is say 2 and this is 7. So what is this distance? How much is the length? We know that this is 5. How do we get 5? 7 minus 2. So in general, if it is A and B, then we know that this length of the interval is always B minus A. In the same way, in our case, we have C and C plus 2L. So to get the width, what we will do? C plus 2L, which is the higher number, minus C. So we can say this C is same, it cancelled out. So this gives you length as 2L. So we say that this is the Fourier series expansion for the function defined over the interval of length . Okay, so let's see how to work with this. First, I'll complete Fourier series, then we'll move to the next topic. So, for instance, if suppose you have this example, find Fourier series expansion for this function fx defined from minus pi to pi. It means the interval is minus pi to pi. Okay, so we have this function fx, interval is this. So what will be length of the interval minus pi to pi? Again, using the same formula, how do we find it? So when we are finding the length, it is pi, which is the higher number, minus of the other number, which is minus pi. So minus minus become plus, pi plus pi. This gives you 2 pi. Okay, so we say that fx is the function which is given by 3x minus pi. Interval is minus pi to pi, and length of the interval is 2 pi. Now, we are going to use this Fourier series expansion which is given by this rule. Okay, function defined on the interval c to c plus 2l with the length 2l. So, the interval is c to c plus 2l, length is 2l. So now as we are going to use this formula of that Fourier series, we compare these two. We compare. Compare means now we say that 2L is equal to 2 pi. When we simplify it, it is L equal to pi. And we get the value of L. So this is the calculation to find L. Clear? What is next after getting the value of L? Next step is, this is the Fourier series expansion where we need to find A0, AN and BN. And we already got the value of A0, AN and BN, the formula. Okay, so let's work on it. First of all, we write this is the Fourier series expansion. The Fourier series for the function fx is equal to 3x minus 5 is given by, what is it, fx, we write down the formula here, a0 over 2 plus summation n from 1 to infinity an cos of n pi x over L plus bn sine n pi x over L. Okay, now we have the value of L from here. Let's substitute it. This gives you a0 over 2 plus summation n from 1 to infinity an cos of n pi x over pi plus bn sine of n pi x over pi. So can we cancel something? Here we can see that pi is the angle, numerator and denominator. We can cancel it. What we did? We replaced L by pi from here. So we
Yes.
substitute pi. So what we left with? We get the Fourier series expansion fx as a0 over 2 plus summation n from 1 to infinity an cos of nx plus bn sine of nx. Okay, so this is the Fourier series expansion, but still we are not done because we don't know what are the values of these terms. We don't know the value of a0, an and bn. So for that we have to use these formulas for a0, and this is for an, and this one is for bn. So let's work on it. Now let's find the value of a0. So a0 is given by 1 over L integral c to c plus 2L fx dx. This is the general formula. Now what information we have? We have our function fx, which is from here 3x minus 5. We are writing down this information. 3x minus 5. The interval is minus pi to pi. And now we add the value of L as pi. So we need these three information to calculate these values. Now this is equal. L is pi, so 1 over pi. Integral. Now it was c plus 2L because here the function is general. The formula is for c to c plus 2L. But for us now in this question it is from minus pi to pi. This we got the things from the question. So minus pi to pi. The value of function from here 3x minus pi dx. So now it becomes a normal definite integral which you can integrate with respect to x. So this is 1 over pi integral of 3x. So 3 is same integration of x. It will become x square by 2 minus 5 times, as there is no x, so integration of 5x. Okay, then the limits is from minus pi to pi. Now we have to replace the values of x with pi and minus pi. So this will give you 1 over pi. 3, I can write 3 over 2 together. This is pi square minus 5 times pi. Okay, this is in one bracket minus 3 over 2. In place of x we have minus pi now, the lower limit. Minus pi square minus 5 times minus pi. Okay, so how we got these terms? These are the limits at x is equal to pi. These are the limits at x is equal to minus pi. Now we just simplify. If we simplify, we see that minus pi square become plus pi square. So this term cancels with this term. And we left with this term. This will minus minus. This will become plus. And then you have minus here. 3 times minus. So after simplifying, you will get this is equal to, say, let me write it here. 1 over pi. This is equal to here minus 5 pi. And here minus 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 3 times minus 5 pi. Same term repeated twice, so it will become 1 over pi minus 10 pi. So again we can cancel pi with pi. So this gives you the value of a naught as minus 10. Okay. So now we will find an. So again the formula for an is 1 over L integral c to c plus 2L fx cosine of n pi x over L dx. So again we are going to use the same thing from the question. Fx is, what is it? This thing, 3x minus 5. The function defined from minus pi to pi with the value of L as pi. So we need this information from the question always. Let's substitute. So it is 1 over pi integral minus pi to pi. Fx is 3x minus 5 cosine of n pi x over L. In place of L we have pi dx. Now before directly going for the integration, it's better to simplify. So here again we have pi with pi, we can cancel it. So we left with now the integral as 1 over pi integration minus pi to pi 3x minus 5 cosine of nx dx. This is the value of an and you need to integrate it. Now you can see it is product of two terms inside the integration sign. So it means, just revising the concept of integration, you cannot integrate it directly because it's not possible to combine it together to make just one term. So you have to go by integration by substitution or by parts, whichever is applicable. So which one is applicable here? So as we can see, two terms under product, and if we look at the rule for cos and x, we have direct rule for this. Even if we look for 3x minus 5, we have direct rule for this term as well. So when direct rules are available for both the terms, we always go by integration by parts, not by substitution. Now for integration by parts, you can use this method u dv, which is uv minus integral of v du. Or we can use, as one of the function is algebraic here, this function is algebraic, we can use even that method, derivative. We select one function for derivative, another for integration. We continue differentiation until we reach 0 and we integrate it same number of times, gives the sign and then cross multiply. So we'll go for this method because this will be shorter compared to this one. So as one of the function is algebraic, we select that algebraic function for derivative and the remaining function for integration. So algebraic function is 3x minus 5 and the other function is cos of nx. The reason we selected this function for derivative because requirement of this method is we should select that function for derivative which after certain derivatives become 0. Like here, if we differentiate 3x minus 5, the derivative will be 3. If we differentiate it again, we reach to 0. This is the requirement that it should end. So we differentiated 2 times, we integrated 2 times. So integration of cos is sine nx divided by n, because we have used the rule cosine of ax plus b dx. This integral is sine of ax plus b divided by a, the coefficient of x, plus c. Now it's a definite integral because we have limits, so we don't add the constant of integration. Now integration of sine, we know that it is minus cosine nx over n square. Okay, now assign the signs for it. Okay, then we start with the sign. It's plus always, we always start with plus, and as we move to the next step we change the sign. So it will be minus and then it will be plus, and then multiply in cross. In cross always multiplication. Now as there are 2 arrows, it means in this integral there will be 2 terms. So let's write it down. So what this will give you? An is equal to this 1 over pi from the question. Now this integral is product of these terms. This sign is plus, this sign is also plus. So 3x minus 5 multiplied by this. And as you can say there are 2 terms, it's always better to put it inside the bracket. Okay, so 3x minus 5 sine nx over n. Now this is minus minus, the sign become plus. 3 multiply cos nx. So 3 times cos of nx over n square. And the limits for x, minus pi to pi. Minus pi to x is equal to pi. What next we have to do? We have to replace x by pi and minus pi here at 3 places, here, at this position and at this position. So these 3 places to be replaced by pi and minus pi, means we are substituting the limit. So let's substitute it. So this gives you 1 over pi 3 times pi minus 5 sine of n pi over n plus 3 times cosine of n pi over n square. So this is for the first term, minus 3 times minus pi minus 5 sine of minus n pi over n plus 3 times cosine of minus n pi over n square. Okay, now it's always better to put the terms in bracket to avoid any mistake. So this is the term when we substitute the limit x is equal to pi, and this entire term should be inside one bracket. This is at x is equal to pi and this is at x is equal to minus pi. Now here we are going to use some standard rule that I will mention here. See, we have the rule that for all n belonging to set of integers, means if say n is 0 or plus or minus 1 or plus or minus 2, we have sine of n pi equal to 0 and cosine of n pi is equal to minus 1 to the power n. So we are going to use these things over here. So let's substitute these values here. So sine n pi is 0, so it means this is 0. And we know that sine of theta, sine of minus x is same as sine of x, right? Minus sine of x, sorry. And cosine of minus x is cosine of x. So the difference between these two will be the sine. So here sine of minus n pi will be 0 again. And for cos value, it's x or minus x, it doesn't matter. So it will be cos n pi from this rule, minus 1 to the power n, and this value also minus 1 to the power n. So this will give you an equal to 1 over pi. Now as this term is 0, 0 multiply anything becomes 0. So this total term becomes 0. Similarly, this third term becomes 0. So we left with here 3 times minus 1 to the power n over n square, and this minus 3 times minus 1 to the power n over n square. So this minus minus, same terms with negative, so this gives you 0. So here we got the value of an as 0. Clear? Now, so similarly we calculate the value of bn, which is given by 1 over n c to c plus 2l fx. In place of cosine, here everything is same. In place of cos you have sine. Sine n pi x over l dx. So the function fx is, say, 3x minus 5, defined from minus pi to pi, with l is equal to pi. Substitute it here. 1 over pi minus pi to pi, fx is 3x minus 5, sine of n pi x over pi dx. So similarly we can cancel this pi with pi. This gives us 1 over pi minus pi to pi 3x minus 5 sine of nx dx. Again, two terms under product, and then we have rules for both of them. We have to integrate it by parts. So we are going to use the same method as we have used here. That will be easier one. So we select one function for derivative, another for integration. So for differentiation, we select the algebraic function, which is 3x minus 5. And for integration, we select the other function, the trigonometric function, sine of nx. And we follow the same procedure. 3x minus 5, derivative is 3. Derivative of 3 is 0. So we stop here. Integration of sine is minus cosine nx over n. Integration of minus cosine is minus sine nx over n square. Then we give the sign plus, minus, plus, and multiply in cross. Okay, so once we done with this thing, we'll come to the bn. So bn will be 1 over pi. Again, we should put inside the bracket. Now it is plus minus gives you minus 3x minus 5 cosine of nx over n. And this minus minus become plus 3 times sine of nx over n square. And the limits is from minus pi to x is equal to pi. So now we have to substitute the limits at 3 places. Here again x, here and here. So let's substitute the limits. This is equal to 1 over pi minus of, when we replace x by pi, 3 pi minus 5 cosine of n pi over n plus 3 times sine of n pi over n square. These are the limits when x is pi. Minus of, when we replace x by minus pi, this minus sign already there, minus 3 times minus pi minus 5 cosine of minus n pi over n plus 3 times sine of minus n pi over n square. Okay, so we have these limits. Now after that, what we have to do? We have to use again this rule. Sine n pi is 0 and cosine of n pi is minus 1 to the power n. So sine n pi is 0, sine of minus n pi will be 0. Cosine of n pi minus 1 to the power n. Cosine of minus n pi also this. So this term cancels to 0, this term cancels to 0. It will become Bn is equal to 1 over pi minus of 3 pi minus 5 minus 1 to the power n over n. And this minus become plus. This become minus 3 pi minus 5 minus 1 to the power n over n. Okay, now it's always better to simplify it further. So to simplify it further, we multiply this term inside to the both terms. We multiply it inside. Okay, so this will give you 1 over pi minus 3 pi minus 1 to the power n over n. Minus become plus. 5 times minus 1 to the power n over n. This is minus 3 pi minus 1 to the power n over n and minus 5 minus 1 to the power n over n. Okay, so some terms cancel here. We can see that this term cancels with this and these two terms are same with negative sign. So it will give you 1 over pi minus 6 pi minus 1 to the power n over n. So we can cancel pi with pi. So you get the final value of Bn as minus 6 minus 1 to the power n over n. So this is the final value of Bn. So now we have all the three values. We have the value of A0, we have the value of An and the value of Bn. We have to substitute all these values in the rule. Let's substitute it. So it will give you, the Fourier series is given by A0. The value of A0 is minus 10 plus summation n going from 1 to infinity An, which is 0, cosine of nx, plus Bn is minus 6. So we can write minus 6 minus 1 to the power n over n sine of nx, so which can be further written as minus 10, and this minus sign outside, 6 outside, because 6 is not affecting the summation. So 6 is not affecting the summation, we can take it outside, minus 1 to the power n over n sine of nx. So this is the Fourier series expansion of the given function 3x minus 5. Okay, this is how we work on it.